Now I'll randomly select some samples one at a time. When I click on Draw Samples, it's going to give me one sample of 30 people, and it's going to calculate the mean of the sample. So the 30 people that it selected have a sample mean of 7.592, and it plotted the sample mean down here. If I click on Draw Samples again, it's going to take one new sample of 30 people and calculate the sample mean. So this time the sample mean came out to 8.275, and it plotted the mean of the second sample right here. If we keep doing this over and over again, what we're going to notice is that each time a sample is selected, the sample is still going to include a lot of people from the low end of the population. That's because there's a lot of people to draw from down here. But since we're using a larger sample size of 30, there's going to be a few more higher people mixed in. And those higher people will bring up the sample mean so that the sample means don't pile up at the low end as much as they did before. And that's going to make the sample means follow a normal distribution instead of the skewed shape that we saw with a smaller sample size. So like right here, notice how these higher people who were mixed in to the sample are bringing up the sample mean. So now the sample means are going to follow a normal distribution, even though the population that the samples are coming from is skewed. That's the last point that the central limit theorem makes. So now that I've covered the central limit theorem, and I've talked about how the shape of the sampling distribution is predictable, I'll go through a few examples with you of creating sampling distributions with a really small population of 4 people. And the reason why I want to go through those examples with you is just because I think those examples will help make the idea of a sampling distribution more concrete and more understandable.